Started. Questions on the homework? Questions on any of the homework assignments? All right. Are we ready for the lesson today? First thing we're going to do is add these polynomial functions together. Now, there's two ways we can add. One of them is vertically, the other is horizontally. Up to this point, especially in Algebra 1, all we did was add horizontally. Now, vertically is not any different, it just looks a little different. Because what we're going to do is take the first expression and write it out. So 3x cubed plus 2x squared minus x minus 7. Now, if there's any gaps, any of them that are missing, we can leave a spot or plug it in as 0. Because if they gave us the x cubed term but no x squared term, we leave a space. Just because, again, if the other one has x squared, we need it to line up. Because if we look at the other expression, we do have x cubed, and we're going to put it under the x cubed term. Our negative 10x squared is going to go underneath our 2x squared. However, we do not have an x term. So what we can do is either A, leave it blank and just go plus 8 and put it underneath the 7, or we can say plus 0x. So we can either put in 0x for that missing term or just leave it blank. So if we're missing a term, we can either add it in as 0 times whatever the variable to that exponent is, or just leave a spot where it's missing because there isn't one. Because we don't want to misalign like terms. Well, it told us to add, so we're going to add the like terms. So we're going to do 3x cubed plus x cubed. 3 plus 1 is 4x cubed. Then we'll move on to the next one, 2x squared plus negative 10x squared. 2x squared minus 10x squared. 2 minus 10. Negative 8x squared. Negative x plus 0x. Negative 1 plus 0. Negative x. Negative 1x. And lastly, negative 7 plus 8 is plus 1. That's it. Yeah. So we just set it up and combine like terms. Questions on this here? So we'll see horizontal here in a second. Yeah. Coincidence more than anything else. So any questions on vertical, how we added these vertically? So what we're going to look at next is adding 2 horizontally. So vertically is up and down. Horizontally is our left and right. So the first thing we're going to do is just write it out. This is what we're used to seeing. This is how we normally add these polynomials, these expressions together. We normally add them horizontally. Just a line with our parentheses around both expressions. Questions on this so far? Now our first set of parentheses, is there a number or sign in front of it? Is there anything in front of the first set of parentheses? No. So do I really need the parentheses? No. So we can just drop them. Well, the only thing in front of our second set of parentheses is the plus sign. So realistically, our second set of parentheses, we can drop them too. So it gives us negative 5y squared plus y minus 4. Realistically, what we're doing is we're multiplying through by positive 1. Well, 1 times negative 5y squared is still negative 5y squared. 1 times positive 1 times y is still positive y. And positive 1 times negative 4 is, lo and behold, negative 4. Because with addition, it's really not going to affect either one of these parentheses. We're not multiplying through anything. It stays the exact same. Now we're going to combine like terms, and we want to keep it in standard form. So we look through and find the term with the biggest exponent attached to a variable. 9y cubed. Does it have any like terms? Nope, so it's still going to be 9y cubed. Which means our next set of like terms is our y squareds. So we have 3y squared negative 5y squared. Yes, because 3y squared minus 5y squared is indeed negative 2y squared. Then we can move on to our y terms. Negative 2y plus y. Negative y. And lastly, 1 minus 4, negative 3. Yeah. On the homework, on the test, when we have these, you pick if you want to do it horizontally or vertically. I do not care which. I went on and showed y'all both so that y'all can see we can do it horizontally, we can do it vertically. Both end up about the same amount of time. Y'all pick. It's up to y'all. Questions on addition? We feel comfortable with addition. Do we need to see another example of addition? No? Okay. Because I do have more addition problems, but if we feel comfortable with this here, we'll just move on to subtraction. Subtraction vertically is going to be almost the exact same thing as when we subtracted horizontal or added vertically. We put our first expression first. So we're wanting to take or subtract 2x cubed plus 6x squared minus x plus 1 from this here. I'm feeling I'm curious. Questions on how we set this up so far? I have a feeling I did something, but yep. I did it backwards, but I don't care. You all know why I did it backwards.
How did you do it backwards?
Well, yes. Should have been the other way around. Because it says subtract 2x cubed plus 6x minus x plus 1 from, technically, yes. But since I think at this point you all have already written this down, yes? We're going to leave it. Because since it says subtract this from this, it's really going to say we're going to subtract 10 from 7, which would be what? 7 minus 10. So it should be the other way. But luckily for y'all, especially on the homework, it's not going to actually word it this way. It's just going to be, here are the two expressions, subtract them. So that is not going to be the case. I have a feeling every single one of my videos I have it done this way. But the bigger thing is that I want to focus on the subtraction and how we do it vertically, not so much how they worded that problem. And I will flip it and I will show you the other way what it wants. Questions on how we set this up? Now, 2x cubed minus 8x cubed. Well, we do 2 minus 8, which is negative 6x cubed. Negative 6x squared minus negative 2x squared. Well, the negative and negative make a positive, giving us plus 8x squared. Thank you. Errors galore. There we go. Yep, got the rest of it right. Which would give us 9. 9x squared. Negative x minus negative 2x. Negative negative again would give us plus. So negative x plus 2x is plus x. 1 minus 9. Negative 8. So this is how the problem was supposed to be set up. And again, we subtract from each other. Now, unfortunately, subtraction, unlike addition, is not closed. So if we do this here, 6x or 8x cubed minus 2x cubed is 6x cubed. Negative 3x squared minus 6x squared, negative 9x squared. Negative 2x minus negative x. Negative and negative make a plus, giving us negative x. And 9 minus 1 is positive 8. Yeah, you can just put it on my desk. So really, for the most part, especially with subtraction, if we end up getting the wrong order, we get essentially all the same numbers, but the signs are flipped. Questions on this here? I would not be surprised if this is, if I've missed this every single time that it wanted it the other way. Does it make sense how we subtract? Yes. Luckily, even on the test, I'm not going to word it. I'm just going to literally start you out with the subtraction part. Are you ready for the next one? Now, the one that we're used to, all right, we'll do it this way. I might reword this problem from now on. Is that we're doing 2z squared plus 3z minus 3z squared plus z minus 4. So when we do it horizontally, we're doing it this way here. Now, we're used to seeing it this way, this horizontal form. Now, the first set of parentheses we can just drop. 2z squared plus 3z. In the second one, we're going to have to distribute that negative through. So the positive 3z squared is going to become negative 3z squared. Our positive z is going to become negative z. And our negative 4 is going to become positive 4. Because the biggest thing with doing it horizontally is we do need to make sure we distribute that negative through. And lastly, we're going to combine like terms. Our 2z squared and negative 3z squared. 2 minus 3 is going to be negative 1z squared. Our next set, 3z minus z, is plus 2z plus 4. And that's it. Questions with subtraction. Do you feel good with subtraction besides the funky wording? Questions on anything we've done so far? We need to see another example of how to subtract. Because luckily for us, all the problems on the homework are going to show up like this. Not an actual word form subtract. Yeah, you just do the addition or subtraction. Multiplication is next. Bless you. Now, luckily for us here, multiplication order doesn't matter. Unlike matrices, where order does, here order doesn't matter. We can multiply any two things in any order and still get the same answer. So we're going to sit the two expressions next to each other inside parentheses. And we're going to distribute. We're going to multiply through. Yes. And the first thing we'll distribute is the negative x squared. So we're going to multiply negative x squared times x. We'll still have the negative. And x squared times x is x cubed. Because when we multiply like bases, we add the exponents. Because I have x squared times x, x times x times x. We have three of them, so it's x to the third. Because even though there's not an exponent, it's understood to be one. Questions on that there? Then we'll do x squared, negative x squared times negative 3. Well, the negative times a negative is an x squared times 3 as well. 3x squared. Because we're really multiplying the 3 with the number in front of our x squared, so negative 3 times our negative 1 gives us plus 3. And we still have x squared. Now we're going to do it again, but with 2x. So I'll do 2x times x, which is going to be plus 2x squared. And lastly, 2x times negative 3. 2 times negative 3 is negative 6x. And last but not least, we're going to multiply through by 4. So we're going to do 4 times x, which is plus 4x. Because it would be 4x squared if the 4 had an x. 4 times x just gives us 4x. And 4 times negative 3 is negative 12. Does that make sense? I might have said 4x there for a second. Now we need to combine like terms before we finish this up. Negative x cubed does not have any like terms, so it's negative x cubed. 3x squared plus 2x squared is going to be plus 5x squared. Negative 6x plus 4x is negative 2x minus 12. Now, most likely, the term, our variable with the biggest exponent, the one that comes first, is normally going to be by itself. And the last term is normally going to be by itself, normally. Questions on this here? We ready for the next one? This time we're going to multiply y plus 5 by 3y squared minus 2y plus 2. Well, we can start with y. We're going to distribute the y to all three terms. Y times 3y squared is going to be 3. Let's stick with it. 3y cubed. Y times negative 2y is going to be negative 2y squared. And lastly, y times positive 2 is plus 2y. And then we're going to do the exact same thing with positive 5. 5 times 3y squared, 5 times 3 is going to be plus 15y squared. 5 times negative 2y is going to be negative 10y. And lastly, 5 times 2 is plus 10. combine like terms. Well, 3y cubed is still the only term with 3y cubed. No other term has y cubed, so it's by itself. Now, negative 2y squared and 15y squared are like terms. Negative 2 plus 15 is going to give us positive 13, and we still have our y squared. Next term is our y term. 2y negative 10y, or 2y minus 10y is negative 8y. And our plus 10 is by itself. So telling us the product of these two here is 3y cubed plus 13y squared minus 8y plus 10.
Like, whatever you just become like, and it takes on what comes first.
As in the variable, or so really all we're doing is y times 3y squared. So we're saying 3y squared times y. Then we'll have negative 2 y times y.
So like, if the first and second one like were like flipped, would you distribute like 3y to y?
So if instead of writing it this way, we wrote it as, okay, now it's just one erase. 3y squared, let's scroll back up, minus 2y plus 2 times y plus 5. We'd still just do the same thing because it'd be 3y squared times y. Then we'd have 3y squared times 5, which would still give us our 15y squared. It's the same thing, it's just flipped. Does that answer your question? Okay. Questions on multiplication? Do we feel comfortable with multiplication? Do we need to see another example with this here? The only other main type we have is this here. But instead of having 2, we have 3. Okay. Now, when we're multiplying 3 expressions together, we're going to pick 2 of them and multiply them together first. Now, the 2 that we pick really doesn't matter. We can pick the x minus 1 and x plus 4. Or we can pick the x plus 4 and x plus 5. The one I normally wouldn't pick is x minus 1 and x plus 5 because we're jumping across 1. You can do it, it just gets a little messy. So normally we just pick the first 2. And we're going to do just like we've been doing. We're going to distribute the x first. Now we would still leave the parentheses because we still have one thing. We have something we have to multiply after this. Now our x times x is x squared. X times 4 is plus 4x. Then we'll do the same thing with negative 1. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. Giving us this here. Now we could start the multiplication process here. We can just start multiplying through. The biggest thing I would say is combine like terms if you have them before we start multiplying again. Now for this here, it's not going to make a big difference. We'll just have 2 extra terms. Because we do have like terms here. 4x and negative x. Well, 4x minus x is 3x. Now this here will still give us the same answer if we left it as 4x minus x or combine it to 3x. I think it'll be a little bit easier to leave it as 3x. Now at this point here, again, we're going to distribute We're going to do x squared times x, which is x cubed. X squared times 5 is plus 5x squared. And after we do that, we'll move on to 3x. 3x times x is plus 3x squared. 3x times 5 is going to be plus 15x. And lastly, negative 4 times x is going to be negative 4x. And negative 4 times 5 is going to be negative 20. And last but not least, we would combine like terms. X cubed still doesn't have any like terms. Our 5x squared plus 3x squared is going to become plus 8x squared. 15x minus 4x is going to be plus 11x. Negative 20 doesn't have any like terms. So we get x cubed plus 8x squared plus 11x minus 20. Questions on this here? Is this really any different than what we did earlier? No, it's the same thing. We just do one set, then do the second set. Questions on any of this here? We need to see another example of multiplication. Are you ready for the next part? And it's not dividing. Now, what we have here is special product patterns. Knowing these, all it does is makes multiplication simpler for some. Not all, but for some. Because the first one we have is the sum and difference of perfect squares. Because our a squared minus b squared factored to a plus b times a minus b. Well, if I have a plus b times a minus b, it should multiply back together to give us a squared minus b squared. First term squared minus second term squared. Same with our squares of a binomial. They have this form, and cubes have this form. So if we look at a, 4n plus 5 times 4n minus 5. That's that perfect square. So what it's telling me is I can go with the shortcut and know that I'm going to square this first term. Well, 4n times 4n is 16n squared minus our 5 times 5, which is 25. So according to that pattern, we can go from 4n plus 5 times 4n minus 5 to 16n squared minus 25. So we didn't remember that. And I went on and multiplied out. 4n times 4n is 16n squared. 4n times negative 5 is negative 20n. 5 times 4n is plus 20n, and 5 times negative 5 is negative 25. Now, what is 20n or negative 20n plus 20n? 0. Which still gets us to what? 16n squared minus 25. We'll still get there. We'll still get to the same place if we multiply through. It's just if we notice that pattern, we can get there a little quicker. That's the only benefit from it. Does that make sense? Because 9y minus 2, according to the square of a binomial, according to this property, really it's saying that this is going to become 81y squared minus 36y plus 4. Is how this should factor, where a is 9y, b is 2, and we could go through those, or negative 2. But all this is saying, when we square something, is we're multiplying it by itself. So we're just saying 9y minus 2 times 9y minus 2. Well, 9y times 9y is going to be 81y squared. 9y times negative 2 is going to be negative 18y. Negative 2 times 9y is going to be negative 18y. And lastly, negative 2 times negative 2 is plus 4. Combine like terms, and we get 81y squared minus 36y plus 4. And again, one of them is just a little bit quicker than the other. Questions on this here? We kind of see how that works. Now, for the most part, what we'll do, multiplying them out and knowing the shortcut's not going to make a whole lot of difference. They're going to end up working about the same. Now, there is, especially once we start getting to bigger powers like 9y minus 2 squared, where it's not squared, we're talking about 7th, 8th, 10th power, the shortcuts start becoming a lot faster. And one way that we get there is Pascal's triangle. Pascal's triangle gives us a setup for how to actually factor these out with given terms A and B, the first and second term. Now that A and B's actually work out kind of nicely. So it's easier to see, we'll pick the third row. So we start out with 3. So we have a to the third, a squared, a to the first, a to the 0. The powers of A are decreasing. Powers of B are actually increasing because the first one is b to the 0. Well, anything to the 0 power is 1, so we don't have to write it because it's a to the third times 1, a to the third. So it's going b to the 0, b to the first, b squared, b cubed. It's going up, the other's going down. Not too bad. And the numbers, the ones in blue, actually build off of each other. Now, it always starts off with this triangle of 1s up at the top, 1, 1, 1. And from there, the 1s diagonal out. So each new successive row is always going to be 1, okay? Now, ready to see how the rest of this thing fills in. It's actually kind of neat. I think it is. 1 and 1 is 2, yes? So the next row, 1 and 2 is 3. 2 and 1 is 3. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4, and then we have our 1. 1 and 5, 4 and 6, 6 and 4, 4 and 1. We kind of see how they make the tree. Now, if we wanted to go farther down, well, we'd have 1 to start with. 5 and 1 would give us 6. 5 and 10 would be 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 20. We get that there. And we could keep going for each successive row. And what's interesting is that no matter what we have, so if we said x plus 1 to the 6th power, we could actually factor it using this tree. Because a in this case would be x, b in this case would be 1. So we take our numbers going across the top. So it'd be 1 times a to the 6, really b to the 0. Plus our next term is 6 times x to the 5th, our b to the 1st. Plus 15 times x to the 4th, a to the 2nd, plus 20, x to the 3rd, b to the 3rd, plus 15, x squared, a to the 4th, 6 times x to the 1st, b to the 5th, plus, really, there's not a whole lot to this. This is above and beyond. Because A and B, A is going to start out to the 6th power and go from the 6th to the 5th to the 4th to the 3rd to the 2nd to the 1st, and then it's gone. B goes from 0, 1, 2, 3, 4, 5, 6. Well, x to the 6 is, because both of these just become 1, so it's x to the 6. Plus, we still have 6 x to the 5th times 1. This is still just going to be 1 across all of them. plus 15x to the fourth plus 20x cubed plus 15x squared plus 6x plus, so x plus 1 to the 6th power is x to the 6th plus 6x to the 5th plus 15x to the 4th plus 20x cubed plus 15x squared plus 6x plus 1. Now, this seems like a lot. Why is this faster? The alternative to find this is to do this. 2, 3, 4, 5. Is to multiply all 6 of those together. So again, with the squares and the 2 that we did before, multiplying it out and doing the shortcut, there's really no difference. It's going to take you much longer to actually multiply x plus 1 by itself 6 times than it is to do the shortcut. Will we do x plus 1 to the 6 on homework or test? No. But it is something we do have. And this shortcut does make things a little bit nicer. Now, when we come back from Christmas break, I will put up a tree. It's one that I hand-drawn. It's Pascal's Christmas tree. So it will be the Pascal's triangle made up like a Christmas tree. But that's it.